thank you. Yes, I do love obscurity, not from a secretive point of view, but to bring anything that's obscure to a level that can be made easy for people to follow and implement on it. So the obscurity was more from a requirements perspective, not from a person exorcism perspective, more like software exorcism. Thank you very much. How many of you here have worked in companies that have systems that are maybe 30 years old, 40 years old, maybe 80 years old? Anybody from mainframes here? Awesome. And are there anybody who has worked in, say, DOS environment or WAX environment? Awesome, even better. So we'll have some flavors here today. What I'm going to talk about today is about modernizing legacy systems. What we deploy today becomes legacy tomorrow. So it doesn't matter whether it's Go, Python, Java, C, C++, COBOL, whatever. We deploy today. If we do not properly architect them, we do not design them well, they are legacy tomorrow. It may not be the legacy we want it to be tomorrow. Legacy has actually gotten a negative, can I use the word connotation here? A kind of a negativity towards any kind of development systems. We struggle with it. We struggle trying to maintain not only the systems, but also the data that's being processed by these systems. How can we then move with maintaining these systems, evolving these systems is the core of this talk. What you will not find in this talk, I want to be very clear what you will not find. I will not be giving a solution to every legacy problem. I'm also not allowed to talk about the eventual solution that we have chosen for 3 of our clients here. One, because I did not, they said, no way you're going to talk about our systems and all the crap we had in our company and how you moved it to whether it is SDN based or a virtual system based or a cloud based architecture. So given that I have been asked not to do those, I have made it very generic, but I want to focus on the what you can do. What are the steps you can do? What can you do to follow? Put them in certain bins so you can evaluate what you have today and modernize it as you move along for the future. So it is that step of what I'm going to be focusing on. But to do that, one of the key things that you probably will have to understand is why do you need to modernize? So the ask will always be something extremely ambiguous, something that is, not very clear, probably because the business thinks that when I give you this ask, you know what I'm asking for. This is something we got in 2010 by a service provider. And basically, the VP came in and said, look, we have, in our 3 departments, we have these systems. We want to position so in 10 years' time, we are capable of handling whatever that comes in the future, 10 years from now, and we can still have our legacy data, but we don't have to deal with all the chaos, the problems we have right now with our legacy systems. This is extremely ambiguous, extremely vague. We don't know what the future is, but they already know what the future they want for their organization, for their business, probably because they have something in the markets. And we know that since 2008, or maybe slightly more, that we are in a VUCA environment. VUCA stands for volatility, ambiguity, uncertainty, and complexity. How many of you believe that none of this is true? the other way around. How many of you believe that there is no complexity in anything we do? Ambiguity? So I guess this is true then. We are living in a world of constant change. We are having to deal as architects or as developers or as product managers or engineering managers to deal with every volatility that comes our way. Any kind of ambiguous statements or requirements come our way. We have to deal with every kind of goal that are not very clear or has no clarity. So we have to keep connecting, communicating, and collaborating to make sure we can identify what our target systems would be and move towards that target system, which again may be constantly changing. And in that sense, I'm going to provide you the outline of how I'll be presenting my materials, of what we have done. This is a culmination of work for the last almost 9-10 years, and we have a methodology, and we have also incorporated an upcoming standard 42030. It's an ISO standard for architecture evaluation. And a disclaimer here, I am one of the reviewers, so I'm kind of part of the team that is developing the standard. ATAM is one of the many evaluation methods that is part of the standard. The way we start, or the way I'm going to present, is I'm going to be presenting the context to which in all the 3 organizations I have worked with, the why we wanted to migrate the legacy systems, what were the challenges in those legacy systems, and how did we develop our formula, what is the thing that we saw and formalized the path to modernization, but what is the key first step to be done, and then provide how can we implement them, how do we, what are the things that we need to look at, the governance aspects of it as we move forward with our target architecture. What are the gotchas? What are the mistakes we have made, thereby learned from it? I keep making some of the same mistakes. I cannot change that. But can I? Maybe I can. Maybe I'm succumbing to Peter principle. Not sure. How many of you also have some kind of management background? Awesome. How many of you have watched Baby Boss? Oh, no kids here. I would highly recommend you watch Baby Boss. It's not a kids movie. It's more a grown-up movie. Office Space, Milton's my friend. So I've tried to put some, instead of giving you boxes and rectangles and all these geometric figures and putting it into multiple slides, I've tried to put my favorite cartoon character, Dilbert, to send a message across in my presentations. All of these are from the dilbert.com website, and some of the other ones to images that I have used to send a message across are also identified there, the source of those images. Eventually, I'll come and talk about what the end outcome was and the policy, basically the lessons learned in the end. And I hope to do that in 30 minutes, which means on certain slides I may spend more time, few other slides I may just skip and move forward, mainly because I would have already talked about them. From a contextual point of view, I don't know how many of you know Daniel Burrus. Daniel Burrus is one of the people who talks a lot about technology disruptions, and he talks widely about business strategy. He did mention that when you want to do something, It is not about just keeping up with the competition. You need to go beyond competition. Now, why is this important? It's because when you are modernizing your legacy system, a legacy system like this, which is spread all over the place and maps to multiple technologies, new and old, you need to not only think about the current competition, but who can be in the future. One of the things that this one is a kind of a, drill down or a dumbed down version of the legacy system we had been given. We had several applications. For example, we had a T1 line and a modem, and then there were a couple of devices connected to it. Nobody knew what those devices were. Don't touch that. I didn't even touch that. I was just there. Don't touch that. That was the shout from the back when I just went close to the modem to look at what is the make of that modem. People were afraid to touch that. Why? That modem was the one that was getting data from some of the manholes that were dug in 1920s and 1930s. And last time somebody touched that, a life was almost lost. Almost, I say, because they didn't die, but the thing is, it was sensitive. We were getting data from that particular device. That device was put in place in 1993, and it was a Hayes modem. Those V90, the latest technology modems at that time. Nobody knew what that does. There was a couple other apps there. Some of them was from VAX system, and I'm still struggling. Even today, we did not modernize it because nobody knew that that big beast is still there. But we have formulated a plan to move away. Any data that goes there is replicated to another system, and it moves to another. So we have two lines there. There were several protocol analyzers, network analyzers, and old and new. Some Agilent systems from the 80s, I think, and some from 2008 existing. Analyzing the network lines, trying to figure out, okay, this particular line is giving me data of like say 20 megabits, while the other line was 0.2 kilobits. The key thing is that all of these systems existed because they could not they did not think about maintaining it. Think about how are they evolving it in the future. Talking to all of these clients, I brought it down to two versions why system would evolve in any such organization. Either the person leaves the company, so you are holding a sack of potatoes that nobody knows, and you have Dilbert using words rhyming with maybe a duck tart. Or you have somebody coming in saying, hey, we have the greatest technology in this world, use this. Rhymes with anything new, and one of my clients actually used a cloud from one of the bigger companies. They didn't know why they were using cloud, but hey, it's part of the bandwagon today. It's a keyword. They used it, but none of the apps that they had was ported to that. It was just there. That system's there. They are paying for it. This is the thing is this is generally how evolution ends up to be. You are given the buzzword to end up. So who is the decision maker? Most of the time, it's somebody controlling the purses. The key thing now as an architect or as your department is to figure out a way to convince the decider, and that's the key. And if you look at ATAM, ATAM talks about risks, but it does not talk about convincing the decider. And the goal of this is to convince the decider, and this is what we did. Considering the challenge we had to rise above it, and we had to figure out what it is that was plaguing us. It's not that technology isn't there. Technology is there, but it's only as reliable as the user who is using it. So we needed to understand the user. And one of the best ways to understand the user is what are their standard operating procedures in their company. And in the companies we have worked for, they did have very good development activities. But when you look at the architectural part, they have it in their process, but they may not generally be practicing it. There may be different levels of architecture that they may be using, but they may not be communicating across. This is an architectural style, except if you look here, it's more a tiered style of architecture. And in many companies, they are doing either bits or parts of it. How do we, gel them all together? TOGAF provides a perspective. It brings in the business, the application, and the technology from an information, behavior, and a structure point of view, but it's still a development process. Step in the ISO 42030. There is a process in place. It provides you a mechanism of how you can put this structure in place so you can modernize your legacy systems. It's not meant just for modernizing legacy system, but it's in what I'm talking about now is about modernizing legacy systems. And in that, I'm going to be concentrating on this part, and in particular, the green aspect of this flow. Why do we need to do the architecture evaluation? Anyone having to spend some time to describe the system, particularly a legacy system, and found that whatever you said didn't go through? I've had that experience. Not only myself trying to explain a legacy system I had been part of, but also when asked to people to describe the legacy system. And this is the key. It's not the architecture you have, it's not the documents you have, but it's trying to describe what the system does. Evaluation helps you do that. What is evaluation then? Evaluation is essentially two things. One, you are assessing if your architecture is complete, and second, if it is consistent. So it is consistent to your business or system needs. And from that perspective, we need to set up a context, and that is our framework. Whatever evaluation we need to do, we need to end up with a plan that will guide my framework to address the concerns of all stakeholders. I cannot talk about the past, but I can make an assumption, and hopefully it's not the odd couple kind of assumptions, making an ass of you and me, but hopefully understanding whatever implicit or explicit assumptions that were made for the system in terms of the concerns of the stakeholders at that particular time. And therefore, we evaluate those entities based on a framework of understanding who the users were and are. So these are the actors in such a framework, of which you probably will nominate an evaluator and a leader. In most of the cases, I was both the evaluator and the leader. To do the evaluation, identify the participation teams and make sure whether there's an architect or a design person, every person is there, talk to them and try to understand what their system does. Essentially, it is not about you have an architecture of the system for the legacy system. It's it is to understand what that system does. And for that purposes, we use the evaluation framework where we put the evaluation approach. Once the evaluation approach will have certain assessment of the values and on which we will analyze the entity. Now, this analysis part is where ATAM plays a role. Then we talk about values. Value is what you ascertain that system to be, or what that concern to be. Value is extremely subjective. So it's based on your judgment, while the analysis is factual. So if you take a look at ATAM, for example, it's extremely factual. Even though it's scenario-based analysis, it is extremely factual, but then you need to step one step higher and identify how you would assess the value, and that's where it becomes subjective, and you may go through one or two rounds before you identify what the value of that system would be. Basically, it means that we have some kind of factors that we have to use at each of these steps, and they translate up to the evaluation synthesis. In what we did, the challenge was the concerns. We had like so many concerns, and they were, I think we identified at one point something like 52 concerns. You think of anything in the textbook, it was there. And every stakeholder said, oh, that's a concern, that's a concern. And then we had to we could group them into different quality attributes. But the key is that one of the lessons learned we had was do not go beyond 5 attributes. Do not go beyond 5 concerns. The moment you go beyond 5 concerns, you are setting yourself up for failure. It becomes more difficult to migrate your legacy system. Prioritize them. The top 3 gets the billing. The next 2 is something nice to have. With that, what we did after working, we identified them and identified the 5 concerns we need to have. This is for just one of the networking element for which availability, capacity, performance, reliability, and interoperability were identified as concerns. And reliability and interoperability surprisingly became number 3 and 4, which were nice to have, but we were able to achieve it in the end. So the key here is that as you're evaluating and putting your framework in place, identify the concerns, narrow it down, bring it down to 5, a manageable 3. 3 is the top one, and of the 3, what's that one? Keep that one, because if that is not there, nothing else, everything else, whatever you get doesn't matter. You have to achieve that one particular concern. How did we get to those? Is by evaluating. So with 42030, which provides us the framework, we could evaluate at different levels. You remember the levels of architecture I gave before: the enterprise, the business, the data, the solutions, the applications we have, the infrastructures. At each level, we can evaluate now. Can I put ATAM there? Yes, with small modifications here and there. It's still scenario-based analysis, so I can put them in each of the levels. And that's what we did here. And I'm giving you some examples of how we identified, for example, stakeholder concerns. We identified the stakeholder, what their concerns were. And then we you synthesize the evaluation, identify what their factors are. One of the objectives we had in the planning was to, what's the current business solutions? So what is the factor that is driving this legacy system migration? Identify, the factor as the business pressures and the impact on those decisions. And we got the stakeholders' approval and them to actually do a factor study. And we came up with a study of the environment. Basically, that was a PESEL analysis that was done. And Then we identified how we progress forward with modernizing the system, and then we said, okay, let's do this kind of group and get a understanding of how we are going with the target architecture and modernizing it every 2 weeks. We also did a few of the weighted findings, feasibility analysis with multiple vendors, and identified how we could do the cloud adoption. It was a report that we got, and identifying what kind of network redesign we need to do. Now, how did we get there? That was by first going with the architectural analysis and then doing the value assessment before achieving this. So maybe my presentation I should have done the other way around. So from a software architecture perspective, we actually used both ATAM and what is called the software performance analysis to understand how the legacy system, if we need to move that to the target system, the impacts would be when we are with the new system and the old system, and what could be the migration path. An example is that we had a plain old Java object. It was a applet that was running on some HTML page, but then what happened is that the HTML went away and the Java object was there running on some Unix platform of old Linux platform that was not even, I think it was 0.9 release, something like that. It has never been updated, running off a 486 machine. What we did was first step we did was took that out, made it run on Java, I think it was Java 6 if I recollect correctly, made it run on Java 6, containerized it, put that in Docker container, let it run. So now we got rid of the old platform, but because it was Java and it ran without any issues, that was the first step we did. Then it needed to, we needed to make sure that it could respond to a certain number of requests per second. That's where we, instead of using ATAM, we ended up using SPE. The difference is very simple. In SPE, you kind of modelize it, say for example Markov models. If the input process and the output process, the signals that you get in and out, they are similar if not identical, it will kind of go well with SPE. So you need to be kind of judicious in trying to identify what is the kind of evaluation approach you need to use. That's the key for success here. You cannot just blindly apply ATAM everywhere. It depends. And then you go up, assess the value based on the factors that you have, and then go synthesize your evaluation. And that rolls up further up to your business. And that made us realize what the real ask of the business was at that time. It took us quite some time, took us about 3 months, but that vague statement now, we were able to bring it down to something. It's still vague, but at least we have a direction. So from a unstable, unreliable system, and it was, for many of the systems there had to be rebooted once or twice a day, impacting the operations today. And from a monetary perspective, this is an estimate. What we surmised or assessed was about $18,000 a day. That is a minimum that they were losing because of these different reboots that they were having. That does not include any costs related to adding new features or getting more new customers and all that. which eventually became a target architecture where we built off the Cisco chassis, unified computing chassis. For one of the customers, it was only the databases, their data warehouses, and everything related to their legacy data that was in Cisco. But the other ERP was built off 18 chassis, and the network analyzers, the customer data points, everything was moved to different chassis. The key here is to understand how the hardware, the virtualization, and the cloudification will work together, whether it's at the system layer or the network layer. When you containerize it, when you Dockerize it, your Dockerization basically is a virtualization of the application layer that will sit on an OS. That OS may sit on a virtualized hardware. So, there's like multiple levels of virtualization here, and then may talk to your network either through your virtualized LAN or through a subnet in the LAN or in a different a direct physical connection. But the key thing is to understand that virtualization exists everywhere. It adds that level of complexity in your analysis in the target architecture, and you need to factor this. It may not be there in your legacy system. So, if we need to move what we had before to the new architecture, what would be the approach? Gartner actually proposes a approach that would, has encapsulation, rehosting, replatforming, and so on. But our experience shows that if you have way too many of these, you lose people. So, we formulated it into, we can bring them all into either reuse, reassess, or replace. It kind of becomes very simple when you can group them into, let's reassess it. Should we re-engineer the software because there is some value in it, or should we just discard it? Or can I just reuse it, either putting a wrapper to it or as such because it's actually done well. The key is to understand that if your problem is caused by technology, is it caused by architecture, or is it caused by some functionality in the application? That will help you understand where you need to group this. And once you do that, you can create a decision matrix which will help you understand what are the applications that you need to either reuse, reassess, or to replace. Replace is basically rebuild everything. Key point here is to understand the complexities. Now, with target architectures, there are hidden complexities, and that's the reason it has been identified in red. So, with the governance, contradictions will arise. So, this is probably, as an architect, my favorite part. I really love implementation because it never goes according to plan. One of the key things we understood while going with the modernization is passive resistance. There is going to be a lack of conceptual integrity if you are not going to deal with passive resistance early on in the game. Second thing is the software bloat. Oh, this legacy system did not do this, so let's add, we want A, B, and C feature. Don't. Keep a firm handle when you're modernizing your architecture. API management was a problem. And remember, key thing is that your APIs will tend to grow to the communications that is designed in your organization. And of course, software is very performant. Hardware is bad. Just making a joke here, but Moore's law says that hardware is faster, but your software tends to slow it down. The outcome in the end was that we did have very good performance or reasonable performance. We had acceptable levels of drift. We did have technical debt, not that we did not have technical debt. At least we understood what it was so we could plan for it in the future. Where there was no operational complexity, we had operational complexity and we had to deal with it. It's all because of the hidden complexities that were there in the target architecture. So what mistakes we made and how did we learn? What did we learn? One, we had somebody who was by the book, and that's how she worked. She was a project manager. So she was more involved in completing the plan, making sure there were no flaws in the plan. Lesson learned, have a completed plan, but if there are flaws in the plan, better than no plan at all. But do not make the mistake of trying to make sure the plan is good. Have a basic plan, half a pager, move on. Second, keep talking about the target architecture. People will tend to lose focus. Keep talking about your migration path. Keep talking, keep communicating, always. That would enable focus, and it also helped in democratizing the decision making. Don't put too much store in your AC charts, but make sure that decisions are democratized, because that helps you generate buy-in in your migrations. Identify your obstacles. There were several obstacles, whether it is passive resistance or whether it was feature creep. We had a lot of obstacles. The key is to identify them and overcome them early. And of course, be realistic and not optimistic. We were a bit optimistic. That cost us 2-3 months in time before we recognized what it was, and we were able to pull it back. So that kind of comes to the conclusion that the key here is that when you're trying to modernize your system, the key is to identify the context in which you are trying to modernize it. There are several modernization initiatives that get started. Oh, it's too old, let's just move it to newer systems or newer technologies. Don't. Identify the context. If you have a context, it helps you generate buy-in and evolve the system gracefully as you move forward. Some of the takeaways that we had for the architecture is that your architecture should be talking about more than a system, more than a technology, engineering the right stuff, or the products. Focus, when you are modernizing to the target architecture, focus more on connections, your communications, and your collaborations. Describe your context, describe the intent, and the decisions that has been made to move this to particular architecture. Oh, interesting. All right. I had a last slide with my name and contact information on it. Sorry about that. And that ends my presentation. Thank you very much, guys.